Welcome to Ask and Learn.
We are given a deterministic finite-state automaton, and we are asked to find the language recognized by this automaton. The automaton is located in problem 18 of this chapter. Look at that as a reference. So we see, looking at the figure, that it contains three states, S0, S1, and S2. Now I'm going to construct a table with two columns. One column contains the states, and the other column will contain the inputs, which can only be 0 or 1. And we see that if there's an arrow from a state Si to a state Sj with a label of x, what we'll do is we'll write down Sj in the row Si and in the column x of the table. So for example, we see that there's an arrow from S0 to S1 with a label of 0. So it follows that I'm going to write down S1 in the row S0 and in the column 0. Likewise, I fill out the rest of the table. So we see that the rest of the table is S2, 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 S1, S2. And we're told that S0 is the start state. Now we see that S0 and S1 are both circled twice, which means they are final states. So it follows that a string is going to be recognized by the automaton if and only if it ends at S0 or S1. Now, let's consider some different cases. So let's suppose that the input is the empty string. Which is lambda. Then we see that, of course, we're not going to move to any other states. We're going to remain at state S0, which is an end, which is a final state. So it follows that lambda is in fact recognized by the automaton. Now, let's suppose that the string starts with a 1. According to our table, we see that we move from state S0 to state S1, or sorry, S2. Now, S1 is a final state, but while we are always going to remain at state S2, because no matter what input we put in, we're going to remain at S2. Problem is, S2 is not a final. S2 is not a final state. So it follows that any string starting with a 1 is not included in the language. Okay, so that's the end of that case. Now let's suppose that the string starts with a 0. And according to our table, we're going to move from state S0 to S1. Now, we're only going to remain at S1 if the string contains only ones after this 0. Then we're going to remain at S1. Otherwise, if we have a 0 besides the first 0, then we're going to move from state S1, according to our table, to state S2, and then we'll have to remain at state S2. So it follows that any string starting with a 0 followed by any number of ones will be in the recognized language. In other words, we have that set 0, set 1 star, it's a subset of LM, and that covers all our cases, so it follows that the language generated by this machine will be the union of all these sets. So L of M is equal to set lambda union with set 0, set 1 star. And this is our answer.